Hello everyone, good evening. So here we shall solve some KCET previous year questions on the chapter Complex Numbers and Quadratic Equations. So any doubts if you have in any steps, then please write that in the comment section. We shall obviously clarify them in the subsequent videos. And in any other chapter of maths, if you have more difficulty, then please write that in the comment section also, so that we can give more priority on it and solve more and more questions on that chapter. And also some important homework questions will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here we have to find the number of solutions for the equation x square minus 5 mod x plus 6 that is equal to 0. So x square I can write it as mod x square also. So if we factorize it, then we will get mod x minus 2 to mod x minus 3 that is equal to 0. So therefore mod x can be equal to 2 or 3. It means that x can be equal to plus or minus 2 or plus or minus 3. So it means that it will have 4 different solutions. 4 solutions are there. So option 1 is the correct answer. Then here it is told to find the smallest positive integer n for which 1 plus I power 2n that is equal to 1 minus I power 2n. So now we can write it as 1 plus I divided by 1 minus I whole power 2n that should be equal to 1. So now if we multiply the numerator and the denominator with 1 plus I, then we will get 1 plus I whole square divided by 1 minus I square whole power 2n that is equal to 1. Since why 1 minus I into 1 plus I that is equal to 1 minus I square. So this, and I square is minus 1, so this will be equal to 2. So this will be 1 plus I square means 1 plus I square plus 2I divided by 2 whole power 2n that is equal to 1. So 1 plus I square is minus 1, so these two will cancel, and 2I by 2 that is I, so I power 2n that is equal to 1. So therefore I power 2n that is equal to, since here the smallest positive integer value of n is being asked, so 1 can be written as I power 4. So therefore 2n should be equal to 4, so n should be equal to 2. So option 2 is the correct answer. Then here it is told that if omega equals to minus 1 plus root 3I by 2, then the value of 3 plus omega plus 3 omega square the whole power 4 is how much? Okay, now we know that 1 plus omega square that is equal to 1, where omega and omega square are the cube roots of 1, cube roots of unity. Since we know that x cube minus 1 equal to 0, if we factorize it, then we'll get x minus 1 into x square plus x plus 1 that is equal to 0. It means that from here the roots of the cube roots of 1 are 1 omega and omega square. 1 plus omega square is 1, so therefore I can say 1 plus omega square so sorry, that is equal to 0. 1 plus omega square that is equal to 0, so 1 plus omega square is minus omega, so therefore 3 plus 3 omega square that will be equal to 3 into 1 plus omega square, that will be equal to 3 into minus omega, so this is equal to minus 3 omega. So therefore this can be written as minus 3 omega plus omega whole power 4, that will be equal to minus 2 omega whole power 4. So this will be equal to 2 power 4 into omega power 4. Now omega cube that is equal to 1, so omega will be omega power 4 that will be equal to omega, so this will be equal to 16 omega. So option 3 is the correct answer. Now here it is given that alpha, beta and gamma are the roots of the equation 2x cube minus 3x square plus 6x plus 1 that is equal to 0. Then the value of alpha square plus beta square plus gamma square is how much? Now alpha square plus beta square plus gamma square, that can be written as alpha plus beta plus gamma whole square minus 2 into minus 2 into alpha beta plus beta gamma plus gamma alpha. So now sum of the roots alpha plus beta plus gamma, that will be equal to minus b by a, so this is 3 by 2, and alpha beta plus beta gamma plus gamma alpha, that will be equal to minus c by a, sorry, that is c by a, so this will be 6 by 2, that is 3. So this we can write it as 3 by 2 whole square minus 2 into 3. So this will be equal to 9 by 4 minus 6. So this is 9 by 4 minus 4 6 4 6 are 24. So this will be minus 15 over 4. Option 1 is the correct answer. Then here it is asked to find the amplitude of this complex number, which is 1 plus I root 3 by root 3 plus I. So this will be equal to 1 plus I root 3 into root 3 minus I divided by root 3 plus I into root 3 minus I. So this will be equal to root 3 minus I plus 3I, then minus I square root 3. That divided by 3 minus I square. So this will be equal to, will be plus root 3. Root 3 plus root 3 is minus plus root 3 plus root 3. So that is 2 root 3 plus 2I divided by 4. So this will be root 3 plus I by 2. So therefore the amplitude, therefore we have to find the amplitude of Z. So that will be equal to tan inverse of 1 by root 3. Since why? Since this complex number will be in the first quadrant of the Argand plane. It will be in the first quadrant of the Argand plane. So tan inverse 1 by root 3, that will be equal to pi by 6. So option 4 is the correct answer. Then the modulus and the amplitude of this complex number 1 plus 2I by 1 minus I whole square are how much? So we have to find the modulus of this. So let Z be equal to this. So this will be 1 plus 2I divided by 1 minus, so this is 1 plus I square minus 2I. So this will be equal to I square, and this 1 will cancel out, and then this will be 1 plus 2I. 1 plus 2I divided by 1 plus 2I. So that will be equal to 1. So Z is equal to 1. 1 can be written as 1 plus 0I. So therefore the modulus of Z, that will be equal to 1, and the amplitude of Z, that will be equal to 0 by 1, that will be equal to 0. So amplitude of Z is 0 and mod Z is 1. So option 2 is the correct answer. Then here the real part of this complex number that we have to find. So Z is equal to 1 by 1 plus cos theta plus I sin theta. So this Z can be written as 1 by 1 plus cos theta is 2 cos square theta by 2. This is I into 2 sin theta by 2 into cos theta by 2. So this will be 1 by 2 cos theta by 2, I can take as common, and then I can write 1 by cos theta by 2 plus I sin theta by 2. Z. So this is equal to 1 by 2 cos theta by 2, and this can be written as into cos theta by 2 minus sin theta by 2 minus I sin theta by 2 divided by cos square theta by 2 plus sin square theta by 2. Since y 1 by Z can be written as Z bar by mod Z square. So now this will be equal to cos theta by 2 minus I sin theta by 2 divided by 2 cos theta by 2. So therefore this Z can be written as 1 by 2 minus I tan theta by 2 actually. So therefore the real part of Z, that is equal to half. So option 2 is the correct answer. And here it is told if 1 plus I by 1 minus I whole power x, that is equal to 1, then x is how much? So we can write this as 1 plus I into 1 minus 1 plus I divided by 1 minus I square. whole power x that is equal to 1. We are multiplying the numerator and the denominator by 1 plus I. So this will be 1 plus I whole square divided by 2 whole power x that is equal to 1. So this will be 1 plus I square plus 2I divided by 2 whole power x that is equal to 1. So I square and 1 will cancel and 2 will cancel. So this is I power x that is equal to 1. 1 means I can write I power 4n, where n belongs to n. N is a natural number. Therefore, x will be equal to 4n, where n belongs to n. So option D is the correct answer. Then here it is told that 3x plus I into 4x minus y equals to 6 minus I. So therefore, the real part should be equated with the real part and the imaginary part should be equal to the imaginary part. This can be written as 6 plus I into minus 1. So therefore, the real part, which is 3x, that is equal to 6, and 4x minus y, that should be equal to minus 1. So therefore, x should be equal to 2, and therefore 2 for the 8 minus y, that is minus 1, so y equals to 9. So x is 2 and y is 9. Option B is the correct answer. Then we have to find the modulus of this complex number. So this is z, that is equal to 1 plus I whole square by into 1 plus 3I divided by 2 minus 6I into 2 minus 2I. So this will be 1 plus I square into 1 plus I square plus 2I into this will be 1 plus 3I divided by this will be 2 into 1 minus 3I into 2 into 1 minus I. So this will be 2 and this I square and 1 will cancel out. This is 2I into 1 plus 3I divided by 4 into 1 minus I into 1 plus 1 minus 3I. So 2 2s are 4. Now this can be written as 1 plus 3I divided by 2 into this will be 1 minus 3I minus I plus 3I square. This will be 1 plus 3I by 2 into it will be 3I square means it is minus 3. So 1 minus 3, that is minus 2 minus 4I. So therefore z is equal to 1 plus 3I divided by 2 into minus 2 minus 2 I can take as common outside also. So this will be 1 plus 2I. Now we know that z1 by z2 if we have, and if we take the mod of, we have to, if we want the modulus of that, that will be mod z1 by mod z2. So this can be written as, so mod z, that will be equal to mod of 1 plus 3I divided by mod of minus 4 minus 8I. So this will be the square root of 1 square plus 3 square divided by square root of 4 square plus 8 square. So this will be equal to square root of 1 plus 9 divided by square root of 16 plus 64. So this will be square root of 10 divided by square root of this is 10, then 6, so this is 80. So this is root over 1 by 8 I can tell. So this is 1 by 2 root 2. 1 by 2 root 2 I can write, or I can tell root 2 by 2 root 2 into root 2. So that is equal to root 2 by 4. Root 2 by 4 I can tell. That means option B is the correct answer. So hope all of you have understood the solutions of these questions on complex numbers and quadratic equations. Still any doubts if you have, then please write that in the comments section. And please install our Sapience education application, where we shall upload some important homework questions based on the previous year KCET exam, which shall be helpful for your exam. So thank you everyone. Bye.